and offers the education right from pre-KG to postdoctoral research. And our institution has got multidisciplinary in the fields of pharmacy, nursing, architecture, management, commerce, as well as paramedical sciences. Recently in 2019, we have received National Excellence Education Award and by the National Press Council of India Charitable Trust. Before we start our programs, I would like to mention about this COVID-19. You know, right from the year 2020 January onwards, we were hearing about this COVID-19. It started in Wuhan in China, and then, you know, we were really laughing at in the month of January that what's happening in China. And then people are now dying, and then there are a lot of things are happening. But we never even thought that, you know, this is going to be the worldwide menace. Man could predict even tsunami today, more scientifically, but in the month of January or February, we were not knowing that we could not predict this COVID is going to happen and we are going to suffer. We are yet to have COVID vaccines and COVID drugs for the treatment of COVID virus. And coming to the subject before we go, what has made this COVID to all of us? We have been transformed today, totally. Change is a word which is most of our people, including me, we don't like it. If you have to do some other job from the present function, we don't like it. But you know, this COVID has made our life is totally changed, and we are now telling that change is a way of life. Work from home has taught us many interesting things. We are learning and preparing to face any unfortunate or unforeseen circumstances in life. Life is a very beautiful word containing four letters, W-L-I-F-E, 4 letters, L-I-F-E. But you know, that center 2 letters, I and if, that is called if, that makes us to think a little deeper today. Life is full of ifs. If I get over this, if I get infected, get over and then become again the real life, that's good. If I don't, I will have to die. So we don't know. So if and buts are very common, has become very common. If I pass, what will happen? If I fail, what will happen? We don't know. If I lose marks, what will happen? If I gain good marks, what will happen? Will I be able to stay here? Having gone to the native place, will I be able to come back? Airports are having a lot of problems. Train journey is also a problem. Bus journey is also a problem. We have been seeing that, you know, all the workers today having a tremendous problem. They've gone to their native place and they are not able to come back, and they are not getting the job over there. And such an important situation that today we are really suffering. You know, post-COVID, what is going to happen? We have to become stronger by ourselves. We have to find out a way how to overcome. The most important thing today, the post-COVID, is the immunity boosters. Immunity boosters are in the full swing development. Herbal teas, vitamin C formulations, and vitamin D formulations. Especially this vitamin D, I was reading for the last few days. We all thought that it's a product of it's a product meant for scurvy. And then we thought that, you know, it is very important for metabolic functions, and then we are not going in the sunlight, and then we are mostly in the office. So we don't know what is to be done. But today, they have found out that COVID virus and inflammation and vitamin D has got a good relation. We were really wondering right from the 400 IU when the doctors have started prescribing 16,000 IU per month for 30 days. Now for COVID, they say that to reduce the Effect of inflammation as an anti-inflammatory, they're giving 1 lakh units, 100,000 units. So that's what is the very problem as far as the COVID is concerned. And COVID is going to remain with us for some more time. So we have to improve the immunity, start living with that. And coming to the subject of this 3 days webinar, very interesting topics. You know, to start with, if I tell you that taste of the pudding is in eating. Only by eating we come to know how good is the product, how good is the product that we have made. Like this, in case of our pharmaceuticals and drugs and formulations also, unless we have got good testing methods, we won't be knowing that, you know, what is to be done. Your formulation will be good, but we have to analyze and find out what exactly you are adding. If you are adding paracetamol 500 milligram in a tablet, we should be in a position to recover and see. So there, what is more important is the method development. Analytical method development is the very important thing. Tools may be available, but how to handle that, how to develop a procedure to match with our product. Batch after batch, you should get the same reading, same analysis, very precisely. That's very important. That's what we are going to see in these 3 days. Second one, when it comes to the impurities are very important thing today. Those days have gone. People used to say that my product is the 99% pure, 99.9% pure, and 0.1% is only impurity. But that has made the scientists to see that what is that 0.1%. So we were talking about 0.1%, and subsequently what happened is that it has transformed from percent to parts per million. Parts per million had become parts per billion. Parts per billion has become parts per trillion. So that much impurity only should be having it. And zero impurity is definitely welcome, and it's very difficult to achieve in case of the formulations. Recently, for the last 2 years, I've been hearing from US FDA that in addition to all these impurities, we call as process-related impurities, product-related impurities, specific impurities, unspecified impurities. Now we started hearing that elemental impurities. The elemental impurities, what US FDA has now said that it is not only necessary for the new product submissions, and it is also necessary for the existing pharmaceuticals too. So that's the status today. And today's lecture and tomorrow and day after is focusing only in this analytical method development and impurity profiles. You know what happens, and one has to learn the industry mantras. So you'll be hearing, all of you will be hearing what are the industry mantras. This analytical method development and impurity profile will pave a way to find out tomorrow that how do we go ahead with the QBD, quality by design. Quality by design has been now renamed by US FDA, and the people are started calling that FBD. FBD is not fluid at bed dryer, it is formulation-based development. QRM, ICH guidelines, and you know that DOE is a very important subject. DOEs are also very important. So the industrial mantras that you will be listening tomorrow. And we have 3 important experts. So first expert is the Dr.Mohammed Ishaq. He is going to talk today on analytical method development. He is working as the head of the department of Santiram College of Pharmacy, Nandia. Tomorrow, we are going to have Arun Kumar. He is from the industry with labs and Hyderabad. And he is going to talk about the method development and also validation of the method development in case of formulations by HPLC. Day after tomorrow, Dr. Narendra Kumar Tuluri is going to talk about this impurity profiling, which is the most important subject. So, to summarize that these 3 days are going to be the good days to understand what is important in the analytical method development and also impurity profiling. Dr. Paul Richard is an expert in analytical method development. He is heading our pharmaceutical analysis department, and he is a professor of pharmaceutical analysis. He has taken very keen interest in organizing this webinar. He has rightly selected these three experts in the field. Over to Dr. Paul. Thank you. Dr. Paul? Hello? Are you able to catch me, Dr. Paul?
And now it's my time to introduce today's speaker for this online webinar, Dr.B.Mohammed Ishaq. Saras did a PhD from Department of Pharmaceutical Analysis, University College of Pharmaceutical Sciences, JNU Kakinada, Andhra Pradesh, in the year 2015, and Master of Pharmacy from Center of Pharmaceutical Sciences from JNU Hyderabad in the year 2009, and B.Pharm from Raipur Raghavendra Institute of Pharmaceutical Education and Research, JNTH, in the year 2007. Mohammed Ishaq sir is a very qualified, oriented, dynamic professional with 9 years of teaching experience. Now he's working in Shantiram College of Pharmacy, Nandyal. He's qualified in GATE 2007 with 95 percentile. Sanctioned GATE stipend from ACT from M-Pharm 2007 to 2009. He awarded as a Best Educationist Award and received from International Institute of Education Management, New Delhi, 2015, Best Research Award from Association of Pharmacy Professionals in the year 2019. Sir has got so many memberships like life member from RDT, blood donor, life member of APTI, fellow of Academy of General Education from Manipal University, life member of Association of Pharmacy Professionals, association member of International Institute of Education Management, and sir has did PhD as a title of thesis, development and validation of novel analytical methods from some pharmaceutical ingredients using chromatographic techniques. So I'm very much glad Dr. Mohammed Ishaq will be for this today's speaker, and also on behalf of ABIPER, we are conveying message as Eid Mubarak to Ishaq sir. So we are very much glad to be part of this 3 days online webinar. You can proceed, Ishaq sir.
Yeah, thank you, Dr. Paul. Am I audible, Dr. Paul?
Yes, sir. Yes, sir. Yes.
Thank you so much for the presentation. And at an outstretch, I extend my heartfelt thanks for the principal management of Aditya Bangalore Institute of Pharmacy Education and Research, Bangalore. I extend my heartfelt thanks to Dr. Paranjothy, Director Research, ABIPER. Good morning, Mandal, and happy Ramzan. I'm Dr. B.Mohammed Ishaq, representing before you with my topic of bioanalytical method validation. So, a very right topic has been chosen by Dr. Paul and his team, that is analytical techniques and novel insights in pharmaceutical sciences during COVID-19 pandemic. As just now Dr. Paranjothy sir said, it is we need a strong analytical techniques in order to determine the drug's purity, quality, and as well as the impurities which are present in the dosage forms. Yes, he has rightly pointed out that gone were the days where we used to talk about if our drug formulation is 99% pure, 98% pure, 99.9% pure. Now the regulatory requirements, regulatory agencies are asking, even if it is a 0.1% of impurity is present, what is the characterization of the 0.1% of impurity? So this is one of the most burning, what to say, thirsty area of the pharmaceutical researchers to do to extend their research. At an outstretch today, I am going to look after a topic called bioanalytical method validation. So, as such, drug discovery process and development process. Drug discovery and development process is a well-defined series of activities. It was an always evergreen subject for the research for the pharmacy and healthcare professionals. It is a series of activities which can be split into various steps like discovery of the leads, optimization of the leads, preclinical development. We used to test in the animals, and then once this was done, it will be entered into the clinical evaluation right from the phase 1 to phase 4. At each and every step of this drug development process, we need a cutting edge of the analytical data, cutting edge of pharmacokinetic and dynamic data. Because pharmacokinetic data, if we will get from why we need to do this pharmacokinetic and dynamic data, because in order to make the further stages of research as well as further stages of drug discovery process, and to make the researcher to carry out his research. So in this nutshell, we need two most important parameters, that is pharmacokinetics and pharmacodynamics. Dynamics will be studied depending upon how far the drug is able to reduce the ailment or reduce the disease or disorder, whereas pharmacokinetic data is one of the most important thing what we need to focus on. Because once the drug enters into our body, how the drug is going to travel in our body, in what mechanism the drug is going to here and there, one compartment to another compartment, these all things require a high cutting edge analytical data which has to be presented to the regulatory agencies. This need a very high throughput screening, very high throughput in instrumentation in order to analyze pharmacokinetic data. Well, if it is a new drug compound to enter into the phase 1, phase 2, 3, 4, we need pharmacokinetic data that has to be determined by some hyphenated techniques. But as far as if the already it's a drug is generic in nature, and if any industry want to enter into the market with the same drug compound, then they will be going for just a line extension of the product by controlled release formulation or some other generic material, generic formulations. There, what they need to prove here is they need to prove that the bioequivalence studies. What they need to prove, the aim of the bioequivalence studies is to demonstrate the formulation of an entity or a drug compound having the same bioavailability as that of the market product. So certain regulatory agencies like US FDA, EMEA guidelines will also give the various guidelines for this bioequivalency and bioavailability studies. Bioanalytical method development. At an outstretch, the complete topic I have been designed in this way, the bioanalytical method development and validation. Today's my discussion will be much focused on bioanalytical method validation rather than development and other processes. Because bioanalytical method development is so it all depends upon a researcher's own experiences and as well as some literature review. Based on this, researcher can develop a bioanalytical method. But validation requires a thorough understanding of the guidelines, thorough understanding of what the guidelines says here. So that's why, and of course, we can't even cover all these topics in this time constraint. So that's why my topic for today's presentation will be restricted much on method validation part. I will throw a little bit light on the method development too, sampling processes, various analytical techniques we have, but much of my lecture for today will be restricted towards the method validation. Analytical method development involves the determination of concentration of drugs, metabolites, and some cases both of them in a biological matrix. biological matrices such as plasma, serum, urine, cerebrospinal fluid, sometimes sweat. Like these are all the different types of biological matrix will be used in order to determine the concentrations and metabolites. Why this has to be done? This has to be done in order to establish bioavailability data on certain pharmacokinetic parameters. The compounds can often be measured in several methods. Several analytical methods are there based upon the concentration levels, based upon the property of analytes, based upon the speed of analysis required, cost of the analysis. We choose different types of analytical techniques. So as I said that the overall process will be in this manner. We need a sample, biological matrix. That sample must be processed because as such, the biological sample cannot be injected into any chromatographic system like HPLC or LCMS, whatever it is. So that has to be processed, that has to be purified. The sample must be purified. What is this purification process means? We need to extract the drug from the biological matrix. This step is called as sample processing. After that, we need to choose a right way of analytical technique. Then a development of the method will take place, optimization, followed by the validation, and finally we apply this validated method to study certain pharmacokinetic parameters. Well, the two commonly used biological samples in bioanalysis are either the plasma or serum. You can see here, this is a plasma where the blood will be centrifuged along with the anticoagulant like EDTA or sodium citrate. Then if you centrifuge this drug, you will get the plasma. And this is the serum, a local liquid which oozes out of the clotting of the blood. So this will be obtained by the centrifugation of the blood without anticoagulants. So choice of the plasma or serum depends on various factors. We will use either plasma or we will use a serum in different conditions. Plasma and serum will be used in order to study the drug clearance, half-life, bioavailability, etc., etc. Whereas urine will be used in order to estimate the renal elimination. So why we need to process the sample? Why we need to purify the sample at all? The basic aim to purify the sample, to process the sample, is to remove any protein-related substances, because plasma consists of plasma proteins, some sort of nutrients, salts, dissolved salts, water, analytes, different types of some sort of pathogenic bacteria. All these substances will be present inside the plasma. As such, you can't take the plasma and inject into our HPLC or LCMS. That will make the complete system will get blocked away. In order to prevent the damage to our instrumentation as well as column, we need to purify the process. We need to purify the sample. Substances and as well as elimination of endogenous substances like phospholipids or any other such compounds which will be present generally in the plasma. Which consists of our drug analyte, and then we are going to add the protein precipitating reagents like acetonitrile, methanol, etc. Then it will be stored for some time so that the reaction will take place between the protein of the plasma and the reagents like ACN and methanol. Then we will be centrifuged. After centrifugation, you will collect the supernatant liquid from the vial that will be injected into the chromatographic system. So this is a protein precipitation process. The advantage with the protein precipitation process is very simple, very easy to perform, economical way, but the disadvantage of the protein precipitation process is the recovery rates is too much less when compared with the rest of the two. So this is a solid phase extraction where you are using a special thing called as a cartridge. It is made up of a plastic, and this cartridge at the bottom you can see a polymer. This polymer is going to separate the drugs and other part of the plasma depending upon the affinity. So first of all, we will take a cartridge, then we will be adding some conditioning solvent. Conditioning solvent can be generally water or any other buffer, so that the cartridge, the silica bed or the polymer bed will get wet and as well as conditioned with the solution solvent. Then we will load the sample. Sample here, it is a plasma sample, consists of our analyte and the rest of the debris which is present in the plasma. After that, we will wash the sample with a washing solvent. The washing solvent will be generally chosen depending upon the polarity based, so that it will be wiped away all the unnecessary material except our drug compound. So the washing solvent generally, again, it will be buffers and some organic solvents like ACN, methanol, etc. And finally, we are going to elute our drug compound by the eluent, or in most of the cases, it will be the mobile phase. In this way, see here we are going to take a combination of all the things. This plasma sample consists of drug, analyte, and the rest of the material. And now at the final step, we are going to get only pure analyte molecules. This drop, this analyte molecule, these analyte molecules will be injected into the chromatography system. So this is called solid phase extraction. Coming to the liquid extraction, we are going to extract the compounds depending upon the polarity base. You might have listened, you might have heard about like dissolves like. So polarity molecules, polar molecules are going to dissolve polar solvents, non-polar solvents are going to, non-polar compounds are going to dissolve in the non-polar solvents. Like this, depending upon polarity, we are going to choose and we are going to extract the drug in the liquid extraction. So what type of chromatographic procedure do we employ here? I have, if in an outstretch, you can see here, right from the 50 years back right now, we have a system of HPLC, which is having a limited speed and a limited sensitivity. As the time proceeds, as the development of science and technology and research in this field takes place, we have enormous research has been taken place in this field, and nowadays we have got very good equipment, very good high-end equipments are also available in the field. We have, look at here, HPLC, we will be able to quantify the drugs up to microgram levels to nanogram levels, and a little bit speed and a little bit sensitivity. And if you move on, if as the time goes on, you'll be having HPLC detectors with UV and as well as fluorescence. Still, the time has speed and as well as sensitivity a little bit improved. By the advancement of LCMS, the speed enormously increased and as well as sensitivity too. And nowadays, if you can see, you have a very well and very advanced technique of UPLC, ultra pressure liquid chromatography, and coupled with mass spectrometer, tandem mass spectrometer as a detector, where you can able to detect the drugs at picogram levels with a very high sensitivity and very speed. Just we can analyze the substance, you can analyze the sample in less than 1 minute at picogram levels. That is the capacity of UPLC and MSMS. So like this, depending upon various factors, depending on availability, cost, and cost of the analysis. So depending upon the sensitivity, how much we require, whether we are going to quantify our drugs up to nano picogram levels or microgram levels, depending upon various factors, we are going to choose the type of technique we need. Well, so after completion of the short discussion about development and as well as extraction process, let us focus more on validation. The purpose behind why I am focusing much on validation, because development process, enormous information will be available, and as well as development method development process purely depends, mostly depends on one researcher's self-experience. Of course, trial and error method and science self-experience plays a major role in the development. But validation, we need to be strictly adhered to the guidelines given by the regulatory agencies. We need to understand the concept. We need to understand how to perform the experiment. We need to understand whether the particular parameter has passed or not, depending upon the acceptance criteria. Like this, we need to have a thorough understanding on the regulatory guidelines of all these parameters. So that's why I'm restricting my talk towards much of my talk on this validation parameters. But before going to learn about what exactly bioanalytical method validation, let me just have a reframe of these small things. If you have these things in your brain, then only we can enter into the validation. You will get some good understanding of validation parameters. Reference standard. Reference standard is a highly characterized material with more than 99.5% purity. Generally, it will be obtained by, generally it is available from USP, United States Pharmacopoeia, European Pharmacopoeia, BP and IP, etc. It is highly costly in nature. Working standards, these working standards do not have the purity of their own, instead of which the purity of these substances will be characterized by comparing to the reference standards. So working standards do not have their own purity. Working standards need to be characterized, need to be standardized by comparing with the reference standards. They are also available from the European, pharmacopoeias, but commercially they are also available, like that of Clearsin, a company which manufactures working standard, high purity working standards. So after that, internal standard. Peculiarly, in bioanalytical method validation, we add a specified amount of internal standard for each and every sample we do analyze in bioanalysis. For each and every sample, we used to add a specific amount of internal standard. Why we need to add the internal standard here? Because in order to check the variability due to the analyte loss during the sample processing, while we process the plasma samples, a little amount of the analyte may get lost, maybe due to the precipitation, maybe due to the binding towards the proteins, maybe in the form of solvent extraction processes. A little amount of the analyte molecule may get lost. If our analyte molecule will lost, automatically our IS, internal standard, will also get lost. So in order to check the variability, in order to check the correctness of our analyte, internal standard will be used. Let us have a little bit more understanding about internal standards. Two types of internal standards can be used in this case. They are stable isotope labeled internal standard, or else structurally related compound, that we call it as non-labeled compounds. Stable isotopes. Imagine our drug is metronidazole. Our analyte of interest is metronidazole. Either you can take the metronidazole D4, where the hydrogen atoms has been deteriorated, as our internal standard, or you can also choose the similar drug which will be having a structural resemblance like that of ornidazole as our internal standard. We have a little bit of advantages when you take the deuterated compound, that we will get better accuracy, better precision, as well as better recovery also when compared with structurally related compounds like ornidazole. But it's expensive in nature. Yeah, this is the most important part of validation parameters. Let me tell you that calibration curve standards, accuracy and precision, these three plays a very, very vital role in entire validation procedure or process. Better and clear-cut understanding of these three makes a masters in the validation process. So please pay much attention here, dear audience. Calibration curve standards, calibration curve. In our general term, we used to call it as a linearity response, linearity curve, where we used to establish a relationship between the instrument response towards the drug concentration. So in sometimes it will be directly proportional, you will get a straight line, in sometimes it will be increased and the parabolic curve, like this is all different types of relations we used to establish. So calibration curve or linearity curve standards are called determined to establish a relationship between instruments response, whatever the chromatographic system we are using, let us imagine LCMS, MS or HPLC, whatever, etc. So what is the instrument response to the drug concentration? As per the guidelines, we need to have 6 to 8 non-zero standards. Please do remember this, we need to have the non-zero standards. Zero must not be there. Along with the blank and zero. So what is meant by this blank and zero? Let me explain. So blank is a processor matrix. It can be a plasma or serum from which your analyte has been extracted, is called as processor matrix. Processor matrix is the thing where the analyte has been extracted, is called as processor matrix. Blank sample is one where it is the sample of the processor matrix without analyte. Whereas zero is a processor matrix with internal standard alone. No analyte will be present, no analyte will be spiked in the zero, whereas no analyte and no IS will be spiked in the blank. That is called zero, that is called blank. And of course, we do have the 6 to 8 non-zero standards also. Now, how to decide this range of calibration standards? It all depends upon the Cmax of the drug which we are using, which we are under study. Cmax, concentration max, how much maximum is reached in the blood circulation, that's called Cmax. Upon the Cmax, we are going to decide the calibration curve standards. Please pay attention here, because this step is a very critical step. Depending upon the Cmax, we are going to first fix limit standard 1 and as well as standard 8. Previously, as I said, that we need to have a 6 to 8 non-zero standards. Let us imagine for our study purpose, we are going to take 8 standards. Standard 1 to standard 8. Standard 1 is called as lower limit of quantification, and upper 8th standard is called as upper limit of quantification. Standard 1 is determined based at least 5% of the Cmax, or even less also is allowed. At least 5% is required. Upper limit of quantification will be determined double to the concentration of the Cmax. Let us imagine that Cmax of our drug, as on today, it will be having 50 nanogram per ml. Then, what is the LLOQ lower limit of quantification will be at least 5%. That means we can take 5 nanogram per ml or even less also. We will go less than 5 nanogram per ml in order to establish the sensitivity of our method. So let us imagine, as on today, the Cmax of our drug is 50 nanogram and LLOQ is 1 nanogram per ml. Whereas ULOQ is double the concentration of the Cmax. So as I said, Cmax is 50 nanogram per ml. So UL obviously becomes 100 nanogram per ml. So finally, the range of the study, the calibration range of the study is around 1 to 100 nanogram per ml. So I think it's clear so far. Now, excuse me. Let us talk about the quality control standards. Why do we perform quality control tests for the dosage forms in order to check whether the dosage form is suitable for the intended use, in order to check that dosage form is passed for its quality control standards and to release into the market. Am I right? In the same way, whether an analytical parameter has passed or not will be determined by these quality control standards. 4 stages of quality control standards can be used, can be accommodated or determined. That is LLOQ-QC, lower limit of quantification quality control, low quality control, medium quality control, and high quality control. See, calibration curve standards and QCs plays a very, very vital role in entire validation. If these 2 slides, I'm coming one more slide, if these 3 slides were not understood by you, then validation looks like something like a Korean movie, which you don't understand anything. So please pay much attention here, because the understanding of this plays a 50. So control standards are used in order to, quality control standards are used to determine whether the validation parameter has passed or not. So 4 different standards: LLOQ, QC, LQC, MQC, HQC. LLOQ is called as lower limit of quantification quality control, low quality control, mid quality control, or medium quality control, and high quality control. 4 standards, QC standards will be used. Now, how to decide these concentrations? How to decide LLOQ, how to decide HQC, LQC, and MQC? As per the regulatory guidelines, LLOQ QC will be half of the LLOQ, lower limit of quantification. What is our LLOQ? LLOQ is 1 nanogram per ml. And what is the half of the LLOQ? It will be 0.5 nanogram per ml. Okay. Similarly, how to decide the HQC? HQC is at least 75% of the ULOQ. What is ULOQ now? ULOQ is 100 nanogram per ml. ULOQ is 100 nanogram. How this 100 nanogram has been decided? 100 nanogram has been decided based on the Cmax. Double to the concentration of Cmax is ULOQ. So at least 75% of ULOQ is HQC. Guidelines has given at least, not the at max. So we can use at 75% of ULOQ is minimum, and beyond to the 75% we can choose anything, but less than must be ULOQ. So ULOQ in our study is 100 as we have determined, and now the HQC, let us imagine it will be 85 nanogram per ml. And as per the guidelines of the LLOQ guidelines, and the LLOQ is 3 times more than LQC must be 3 times more than the LLOQ. So that is 3 nanogram per ml, and MQC it will be around 30 to 50% of the ULOQ. Let us imagine it will be 50 nanogram. So please keep these values in your brain so that it will be easy for us in order to understand the validation parameters. So our Cmax is 50, LLOQ is 1 nanogram per ml, ULOQ is 100. Range of the CC is 1 to 100 nanogram per ml. LLOQ, LQC, MQC, and HQC, these are the concentrations. Let us see in a nutshell how does this calibration standards looks like. Calibration standards, as I said, that we will be having standard 1 to standard 8. Standard 1 is called as LLOQ, standard 8 is called as ULOQ. We have already decided that. Previously, we have already decided LLOQ is 1 nanogram, ULOQ is 100 nanogram depending upon the Cmax. Now, how to decide standard 2? Standard 2, as per the guidelines, it is just 2 times to that of standard 1. And standard 3 is 2 times to that of standard 2. Standard 1 is LLOQ, we have already decided. Standard 2 is a double the concentration of standard 1. Standard 3 is a double the concentration of standard 2. So 1 nanogram per ml is standard 1. So double the concentration is 2 nanogram. 2 nanogram is standard 2. And double to this concentration is standard 3, that is 4 nanogram per ml. So at a stretch now we have decided standard 1, standard 2, standard 3, 8. Now how to decide standard 7? Now let us decide standard 7. Standard 7 will be decided depending upon the HQC. The difference between the standard 8 and HQC will be the same depending upon the difference between the standard 7 and HQC. Look at this one. Standard 8 is 100, HQC is 85. 85 were decided in the previous slide. So the difference is 15. And similarly, standard 7 is maintained 15 nanogram per ml difference, and as a result you will get 70 nanogram per ml. So in this way standard 7 will be decided. Now how to decide standard 6? Standard 6 will be decided depending upon the MQC concentration. Look at the difference between these two, MQC and standard 7. It is 20, and the difference between the standard 6 and MQC must also be 20. In this way standard 1, 2, 3, 8, 7, 6 has been decided. And we have decided the LLOQ, LQC, MQC, HQC 2. And finally, we have left with 4 and 5. So there is no hard and fast rule to decide 4 and 5. It can be in between anywhere in between standard 3 and standard 6. So in the study, in the current study, we have decided as 10 and as well as 20 nanogram per ml. So clear understanding of these standards plays a very, very, very critical role in the coming parameters. So so like this, all these parameters has been finalized. I hope you are following the lecture. Now let us understand the acceptance criteria. How do you know that the calibration curve has been accepted? Back calculated concentration of CC standards should be within plus or minus 15% of nominated values, except for LLOQ, which will be plus or minus 20%. Let me explain you what exactly this is. Nominal concentration, nominal value. What is this nominal value? Nominal value is these values, 100, 70, 30, 20, 10. These are the nominal values. That means theoretically determined values are called as nominal values. Back calculated value, what do you mean by back calculated value? Back calculated value is called, it is the experimentally determined value. Experimentally determined values. So back calculated experimentally determined values should be within 15% for all the standards except LLOQ. Should be within 15%. Look at the LLOQ, it has given 20% relaxation. Why it is so? All the rest of the standards must be a 15% plus or minus 15%, and the rest of the standard one, it is 20%. Why? Because the LLOQ is the least concentration, and as you know, as we know that at least concentrations, we do have more number of errors to happen. So when the drug concentration reduces, the accuracy will be information will be less when the more concentrated drug samples. So that's why the level of the allowed percentage of error is plus or minus 20% as case of LLOQ, whereas for all the rest of standards it is 15%. Please do take care of this one. Okay, fine. At least 75% of the CC standard should pass above criteria. That is 75% of, that means more than 6 standards should pass this criteria. That means the level of concentration will be more or less 15%. And area in blank and area in blank at the retention time of analyte, it should be less than 20% of area of LLOQ, and area of area in blank at RP of IS should be less than 5%. Don't worry, it looks a bit confusing and messy. In the coming slides, you will get to know what exactly this is. I will try to simplify as much as I can. I have tried to simplify as much as I can so that you will be having a better understanding for you. And acceptance criteria for quality control standards. At least 67% of the quality control standards should be 15% nominal values. Because in QC in CC, we are using QCs also. These has to pass. These QCs must be passed. How much percentage? 67% of the QCs must be passed. That means out of 4, 3 QCs must pass with a 15% of the nominal values. And more than 50% of the QCs at each level should pass. So this is a simple procedure to prepare the CC and QC standards. QC and CC standards must be prepared as a fresh stock daily. As long as you validate the procedure, you need to prepare the QC and CC standards with a fresh stock solutions. Generally, it is our practice that we will prepare 1 mg per ml as the concentrated drug substance. That is a 1 million nanogram per ml. That's called a stock solution. From this, if you take 0.1 ml and dilute to 10 ml with a diluent, the diluent can be any solvent like acetonitrile, methanol, or any buffer solution. In this case, you will get 10,000 nanogram per ml. We call this as a working standard. From this working standard, 1 ml of the working standard will be diluted to again 10 ml with diluent. We will get serial standards. From this serial standard, we prepare standard solutions. For all the 8 standards, we have to prepare 8 serial standard solutions. Serial standard 1, serial standard 2, serial standard 3, like this, we have to prepare 8 serial standards. From these 8 serial standards, we prepare standard 1, 2, 3, 4, up to 8 in the plasma. So from serial standard, in order to prepare the final concentration of standards, we will use plasma instead of diluent, because ultimately we need to spike the sample in the plasma and then we have to recover. So till now, these are the background, what I have something like movie titles, what I have explained to you. Now the real movie begins. So if you are okay with this previous one, then we will be easy. It will be more easy for me to explain all these parameters. Then those parameters, those reference standards and calibration curves, QCs, all this must be kept in your mind before entering into the method validation parameters. Well, method validation includes all the processes that demonstrate that a particular method is used for a quantitative measurement of analyte in a given biological matrix, are reliable and reproducible for intended use. This is a simple definition. It is a documented evidence. It is a documented evidence that a system, for what it purports to do, this is a validation. Obviously, we all know this. But here in bioanalytical validation, this is also a documented evidence that a particular method is used for the quantification and measurement of analyte in a given biological matrix, and that should produce reproducible results, is called a validation. So these are all the validation guidelines. Actually, FDA guys use validation guidelines. EMEA, European Medical Agency, will also use bioanalytical validation guidelines. ICH has also given validation guidelines. But more or less, all the guidelines are more or less similar with the small differences here and there. And today we will restrict our talk only on the FDA guidelines. Why? Because they are very stringent guidelines when compared with the other rest of guidelines. Highly stringent guidelines when compared with others. So that's why let us talk on FDA guidelines. More or less, all these guidelines are as far as the procedure of experimentation is concerned, which is quite same. Here and there, the acceptance criteria may vary here and there. That's it. So remaining all the things will be quite similar. Well, the validation guidelines which we need to analyze are selectivity, specificity, carryover, precision and accuracy, robustness and ruggedness, matrix effect, recovery, dilution integrity, re-injection reproducibility, and finally stability. So we will talk about one by one what we are going to look after here. We are not going to simply just check the definition and leave the parameter like that. We are going to check what is the definition, what is the purpose behind this, why the FDA or any other guidelines has given these guidelines, what is the need for these guidelines, purpose, And how to perform this? This is the most important. This the point where you are not going to get in textbooks. So how to perform, and finally, how to say that this particular parameter has accepted. That is what to say, whether this parameter has passed. Okay, these are the things what I'm going to explain. We will see about the definition, purpose, how to conduct the experiment, what's the validation, what's the acceptance criteria. Let us talk about the first one, selectivity. It is the extent to which the method can determine the analyte of interest and internal standard in the matrix without any interference due to the matrix components. What is a matrix here? Matrix is any biological matrix like blood, cerebrospinal fluid, serum, urine, etc., etc. We need to prove that our method is highly selective for the determination of only and only analyte and as well as IS only. No other component of the matrix, no other component of any other thing is going to be detected in the chromatogram except our analyte and IS. This is the purpose of this. How do you perform this? We need to have 6 different lots of plasmas, 6 different lots of normal plasmas. That means we collect the plasma from 6 different people, normal individual, normal subjects. 1 plasma will be hemolyzed and 1 plasma will be lipemic plasma. What's the purpose behind using hemolyzed and lipemic plasma? Hemolyzed plasma, there is the overall aim of this validation is to extend the same method for the to carry out the study, to carry out the pharmacokinetic study in the subjects. While you withdraw blood from the subject, there is a chance for the hemolysis of the blood. So in order to establish that, the hemolyzed plasma will also not going to affect anything and anywhere in our study. That's why we need to establish by using 1 hemolyzed plasma. Lipophilic plasma, lipolyzed plasma. Obviously, there will be subjects who are having high profile of lipid content. So in order to establish that lipid content of the plasma is also not going to affect our method. So to determine this, we need to use 6 different lots of plasma, 1 hemolyzed plasma and 1 lipemic plasma. Now, what to prepare from these plasmas? We need to prepare blank and we need to prepare a drug concentration equivalent to LLOQ. How much is LLOQ? 1 nanogram per ml. From each plasma lot, 6 plus 2, 8 plasma lots, we are going to prepare blank and LLOQ concentrations. LLOQ is called as standard 1 for your information. So, how many replicates we need to prepare? At least 3 to 6. At least 3 replicates to 6 replicates we need to prepare. Now, after preparing all these things, we need to inject into the chromatographic system, maybe LC-MS or HPLC. Then we have to check the acceptance criteria. Area in the blank plasmas, we need to concentrate. We have prepared the blanks and as well as LLOQ. So, how to say that the blanks has passed? Exactly at the RT of analyte. The area which should be recorded must be less than 20% as that of area which is recorded in the YOLO. Imagine our RT is around 1 minute. 1 minute is the RT of our. At 1 minute you will be having certain amount of area. And exactly at 1 minute in the blank chromatogram, there should be area recorded less than 20%. Let me explain you with this example. Look at this one. This is a plasma lot 1. This is a plasma lot 2. Plasma lot 1, we have prepared a blank and we have prepared a LLOQ. Remember that we have to prepare blank and LLOQ. Okay. Now we have prepared a blank and we have prepared a LLOQ. So at RT of LLOQ, we have got an area of 1000. Imagine, and at the same RT in blank, it was recorded 10 area units. area units. So 20% of 1000 is 200. So the 200 is less than, the 10 which has been recorded in the blank is less than 200. So that's why this plasma lot is passed. I hope you got the point here. Similarly, look at this another side. This is the plasma lot 2. Here also same, LLOQ has got an area of 1000 at one particular RT. And at the same RT, if the blank has got 250, imagine. Blank is devoid of analyte. Blank must not have any sort of analytes. In fact, any sort of IS also. So blank is having 250. Imagine, and now 20% of 1000 is 200. And whereas the area recorded in the blank is 250, which is more than the 200. So that's why this plasma lot is failed. Okay, like this is the meaning of this acceptance criteria. When you say that selectivity of your method has passed, if the RT at the RT of the analyte, if it is area is less than 20% of LLOQ, then your selectivity is passed. Otherwise, it is failed. So that's about the selectivity. Next comes the specificity, more or less similar to that of selectivity, with small differentiation. Specificity is assessment of a method of ability of the assessment of the method to analyze of the interest in the presence of other components also. What are the other components? Other components may be matrix substances, or it can be co-medication also. As I said, that the aim of the method development and validation is to extend the same method in order to study the various pharmacokinetic parameters in the subjects who used to come for the bioavailability or bioequivalence studies or clinical stages like this. So we are going to extend the same procedure, same method for the analysis of pharmacokinetic parameters in the subjects. So the patients or the subjects who are under study may be having a small fever or body pains or cold, or he may be a smoker, or he may be consuming of coffee. So all the different types of co-medications which are present in his body. For fever, they may use pyrexia, they may use paracetamol. For body pains, they may use ibuprofen. For the cold, general cold, they might have used chlorpheniramine maleate. If the patient or a subject is a smoker, his blood will be having a nicotine, and if the subject is having a habit of drinking coffee, then his blood is having traces of caffeine. So, in specificity, what we are going to prove here is none of the substances which are present in the plasma are going to affect our method. Either it is a plasma substances, plasma related substances, or maybe the co-medication which are present. So none of the substances are going to affect my method. So that is the purpose of the specificity. So how to do this? So in a more similar manner, we need to have 6 plasma lots, 1 normal, 1 hemolyzed, 1 lipemic, along with the co-medication. How much of the co-medication has to be spiked? It again depends upon the Cmax of the co-medication. So one drug will be having 1 Cmax. And we need to prepare 6 LLOQ and 6 LQC concentrations. 6 LLOQ of only of our analyte. No, in each plasma lot, only of our analyte concentration. And 6 LQC of our analyte and as well as co-medication Cmax substances. Let me explain you in a more diagrammatical way so that you will be understood. Look at this one. What we are going to prepare? We are going to prepare blank, LLOQ, and LQC. Blank is devoid of all the analytes. LLOQ, how much is LLOQ in our study? 1 nanogram per ml. And LQC, spiked with the co-medication. Now, look at this. We are going to prepare a blank. Blank does not have our analyte. It is going to be added only the co-medications like paracetamol, ibuprofen, chlorpheniramine maleate, nicotine, caffeine, etc. LLOQ will be prepared only with the analyte, no other medication is present. Whereas LQC will be added to analyte, paracetamol, ibuprofen, and chlorpheniramine maleate. All these will be prepared in a replicates. As I said that we are preparing blank, LLOQ, and LQC. So again, acceptance, all these things will be injected into the chromatographic system. Same acceptance. See, acceptance criteria remains constant throughout the study. If it is a case of blank, the RT of RT and the peak area which has been recorded with the RT of the analyte must be less than 20% of LLOQ, something in this manner, and the RT of the IS must be less than the 5% as far as IS is concerned. So accuracy of the LQC sample should be within plus or minus 15% of the nominal value. So this is the acceptance criteria for the specificity. Next one, carryover. What is carryover? Carryover is the appearance of analyte signals or analyte peak in the blank samples. Excuse me. So carryover is the appearance of the analyte signal in the blank samples. So blank itself means that it is a devoid of an analyte. How will you get the analyte signal in the blank? This is a logic here. when you inject a compound with a high analyte concentration and followed by the injection of the blank sample, there might be a possibility that the high concentrated sample might be, traces of the high concentrated sample might be stuck inside the column itself. So that process, that traces amounts of high concentrated drug sample may carry along with our blank sample. So there is the logic here. So, excuse me. What's the reason behind this? Inappropriate solvent dilution, sample dilution or diluent, inappropriate mobile phase we have used, inappropriate mobile phase pH, washing durations. So all this will be the reasons. What is the remedy for this then? We need to extend the duration of washing. We need to change the mobile phase or diluent. What's the procedure? We need to prove that our method does not have any carryover effect. So how to prove this? We need to inject processed blank samples after high quality control or LLOQ and then in a replicates of 6 times. Again, the same acceptance criteria at RT, analyte must be less than 20% and at of the LLOQ and at RT of IS less than 5% of the LLOQ. So next one is precision and accuracy. Calibration curve standards and precision and accuracy. This plays almost 50% of the validation parameters. These two covers 50% of the validation parameters. Accuracy and precision are a bit lengthy one. Please pay much attention in this case. Precision and accuracy. Precision is called as closeness of agreement between the series of measurements. It will be determined by the standard deviation by mean integrated. And accuracy is a degree of closeness of the determined value to the nominal value. As I said, the nominal value is the theoretical value, and whereas determined value is the experimental value of which we obtain. So determined value divided by nominal value into 100 gives the accuracy. Look at this picture, so you will get to know what is called accuracy and precision. In archery, an archer is hitting here and there. Look at this one. This is the target of an archer, whereas this fellow has hit his targets here and there. This archer is neither accurate nor precise. Let us look at this one. This fellow is almost closely, he is hitting the target, but not repeatedly. This fellow might be accurate, but not precise. Look at this one. This archer is hitting his target exactly at this particular point, not to the target. This fellow is precise because repeatedly he is hitting at one particular target, but not accurate as none of his arrows has hit the target. And this fellow is, this archer has hit to the target and as well as repeatedly hitting to the target. So that's why this archer is regarded as accurate and precise. So what I mean to say from this experiment is experimental procedure and experiment method validation parameter like accuracy and precision must get a correct result, and as well as correct result on every repetition. We must get the correct result. The result must be accurate enough, and as well as the result must be precisely result. That means even if you repeat the repetition, repeat the series of measurements, you must get the correct result. So that is called as accuracy and precision. So what are the requirements for this? Freshly prepared CC concentrations and QC concentrations. Every day we need to prepare fresh concentration. This point is most important. At least 3 runs are required. At least 3 batches of precision and accuracy is required. And these 3 batches must be run in between 2 days. 3 batches of precision and accuracy must be run in 2 days. What is a batch of precision and accuracy? What does a batch contains? Batch of precision and accuracy contains 1 blank, 1 0, calibration curve standards from 1 to 8, QC standards at 4 levels, LLOQ, LQC, MQC and HQC. This complete set consists of 1 PA batch, 1 precision and accuracy batch. So blank without any analyte, 0, only IS, CC standards consists of drug and as well as IS, QC standards also concern drug and IS. So these three batches, these three batches must be run in 2 days. That means today we will run 1 batch, tomorrow we may run the 2nd and 3rd batch. Or else today 1 batch, tomorrow 1 batch, and day after tomorrow another batch. Like this, we have to run in 3 different days, 2 different days at least. And at least 5 samples, 5 replicates for each level of QC. At each level of QC, that means 5 replicates of LLOQ, 5 replicates of L, 5 replicates of M, and 5 replicates of HQC must be there. And only 1 replicate of CC and 1 0 and 1 blank. This completes the set or the batch of the precision and accuracy. These things are much more important because the understanding of the guidelines is this. Guidelines will give the information regarding you need to run the PA batch for 2 days and in this replicates, but they never say that 5 samples, 6 samples like that. These has to be taken care of. So precision and accuracy will be of 2 different types: within the batch run, between the batch run. Within the batch run should be determined by analyzing in a single run at a minimum of sample of each QC at 4 QC samples. That means one batch will be run for one time. That's it. We are not going to repeat for another time. Between the batch run is determination by analyzing for 2 days, as I said earlier. So this is the within and this is the between the batches. Same acceptance criteria. All CC standards should be of 15% except LLOQ, which will be 20%, because as I said that lower concentration will be having more errors, so that's why 20% error is allowed, and higher concentration 15% error is allowed, and at least 75% and minimum of 6 standards should meet the above criteria. Acceptance criteria for blank and zero, same, 20%, less than 20% to that of RT, area, and less than 5% in case of IS. Acceptance criteria for the quality control standards. The mean quality control of each level of the quality control sample should be within plus or minus 15%, and LLOQ must be 20%. Again, look at here. Low, mid, and high has given 15% relaxation, whereas LLOQ QC, which is the least concentrated sample, has given 20% relaxation. Why? Because the concentration is less, errors will be more. As far as precision is concerned, coefficient of variation, percentage CV of all the QCs should not exceed more than 15%, and for LLOQ QC should not exceed 20%. Overall, 67% of the QC standards must pass at 50% at each time. This looks a bit messy and confusing, I know, that's why I'm giving one more small example here. Look at this one. In our study, LLOQ QC is 0.5, if you can remember from the slides, previous slides. 0.500 nanogram per ml is the nominal concentration, theoretical concentration. For LLOQ QC, acceptance criteria is plus or minus 20%. Look at this one. For LLOQ QC, it is 20% allowed. 20% allowed. So therefore, this is the limit, and this is the acceptance range. 0.400 nanogram per ml, 0.600 nanogram per ml is allowed. Imagine that 6 concentrations of LLOQ QC has been injected. All these 6 out of these 6, one has failed because it is beyond this range, acceptance range, 0.60. We'll take the mean of this one, standard deviation of this one, percentage CV. Percentage CV is called as percentage covariance, that is called as precision, will be calculated by using this formula, standard deviation by mean into 100, that is 10.26, and it is passed. Why? Because the acceptance limit is plus or minus 20. Percentage recovery is 1 or 2%, which will be calculated by using this formula. It is also passed. Why? Because LLOQ QC, the percentage recovery allowed error is plus or minus 20%. And at least 50% of the QC sample should pass. Out of 6, 5 samples has passed. That means it has more than 50% pass. So overall, we can say that precision and accuracy is passed. This is the manner how do you calculate the various types of parameters and calculations. And these are the formulas which has been given. You can go through this. And finally, next one is robustness and ruggedness, the ability of analytical method which remains unaffected by small variations in the method parameters, but deliberate method. But intentionally, we modify certain changes like column, instrument, analysis, buffer pH. All these things will be modified, and then it will be checked whether these affects our method or not. So how to perform this one? Evaluating by changing at least one parameter during the run of precision and accuracy. This will be done like this. And the acceptance criteria is same like that of precision and accuracy again. Next one is matrix effect. Direct and indirect alteration of interferences of response due to the presence of unintended analytes. That means effect of matrix, effect of serum or blood or plasma on our response is called as matrix effect. Why we need to concern about matrix effect? Because this creates a lot of problem that it may suppress or enhance the ionization in case of MS if you use mass spectrometer as your detector. And what happens if suppression or enhancement takes place? It may increase or decrease the analyte response. That's the basic problem with this. To explain the matrix effect, look at this particular figure. This is a set 1 where you are going to have the standard solvent extraction. That is, it is not a matrix sample. It is a purely solvent sample, maybe ACN or methanol, whatever. So A is analyte and H plus is our solvent. So when you mix this, what happens? All the A will be attached to the solvent moieties. As a result, you will get 6 analyte molecules. For the 6 analyte molecules, you will get a beautiful peak like this. Look at this set 2, where you are having matrix in this one. Matrix, plasma will be present. There occurs a competition between the matrix and analyte to go and bind with the solvent molecules. As a result, the matrix and the solvent and the matrix and solvent will be having competition. So as a result, a little bit amount of drug compound, analyte molecules will be substituted with the matrix molecules. As a result, you are going to get only 2 analytes here. Look at this. Once it was a 6, all the 6 analytes has attached to the solvent molecules. But here, due to the presence of matrix, a little amount of matrix has been occupied by solvent, and some analyte molecules have also attached. As a result, you are going to get only 2, and the peak response has been reduced. So this is the matrix effect. If the matrix is present, if the plasma is present, the response reduces like this. So that is called as matrix. How to minimize this? So more selective extraction procedures need to be developed. We need to change the buffer as extraction solvent. We need to have a more stable internal standard to minimize this. Now, how to perform this? We need to have 8 different plasma lots. 6 will be normal, 1 will be hemolyzed, 1 will be lipemic. We need to prepare set 1 and set 2 of LQC, MQC, and HQC. Both set 1 and set 2. What is set 1 and set 2? This is set 1 and this is set 2. That is already set 1, and extracted solvent, plasma sample is set 2. Standard solvent without plasma and post-spiked plasma is set 2. What we need to prepare, what concentrations we need to prepare? LQC, MQC, and HQC. So finally, matrix factor will be given by the formula like peak area in the presence of matrix and peak area in the absence of the matrix. So both will be compared. And if it is more than 1, it is called as increased response, ion enhancement taking place. If it is less than 1, ion suppression takes place. This is completely in MS, not in HPLC. So if it is less than 1, ion suppression takes place and the decreases response will get decreased. And if it's exactly 1, no matrix effect will get present. Generally, our method must be in such a way that the matrix effect is nearer to 1. So finally, IS normalized internal standard matrix effect also be calculated, and the acceptance criteria is should not be greater than 15%. Next one, recovery. Extraction efficiency of an analyte process is reported as percentage known amount of analyte recovered from the extraction. That means how much amount of sample has been recovered from the plasma is called as recovery, as simple as this. How to perform this? Recovery might not be 100% in all the cases. It may not be 100% in all the cases. 100% recovery is not at all possible, because little amount of the drug will be binded to the plasma proteins, and that will get wasted. That's fine. That's not a big issue. But the concept of recovery here is it must be consistent. The method must consistently able to recover our drug compounds. So that will be the target. Well, how to perform this? We will be performing in 3 different levels: L, M, and HQC levels. 6 replicates must be taken for extracted, and 6 must be for post-extracted. So finally, the recovery will be calculated by using area of extracted divided by post-spiked sample into 100. So again, it will be same at each QC level. 15% is allowed. So L, M, and H. L, M, and HQC is only 15% is allowed, whereas if you use LLOQQC, it is 20% is allowed. These 2 differences. Next one, another small one, dilution integrity. This experiment is carried out to assess the ability of a method to quantify the analyte and to yield accurate and precise result after sample dilution. What is this dilution integrity? It is a maintenance of same integrity of the results even if you dilute the sample. Why do we dilute the sample? Because whenever you have got a subject with a more concentrated sample beyond to that of our calibration range. What is our calibration range? It is from 0.5 to 100 nanogram per ml. We have decided in the earlier slides. Imagine that you have got a subject with a high concentration, like imagine if you 200 microgram per ml, then we can't just skip that subject. We can't just keep claiming that it is out of the calibration range. We need to analyze the sample also. How to analyze that sample which falls beyond our calibration range. Look at this. For example, if you take an example of our ULOQ is 100 nanogram per ml, and our calibration range is 0.5 to 100 nanogram per ml. And if you have got a sample which is having 200 nanogram per ml, then how to accommodate in our calibration range, calibration set, how to accommodate this 200 nanogram per ml in our calibration set? We need to dilute this. We need to dilute this, and we have to prove that the results are still integrated with that of our method, even after the dilution. How much to dilute? We may dilute for 4 times, we may dilute to 2 times, we may dilute to half, whatever the dilution you do, but it must fall in between the calibration range. Still, it must be integrated with our results. So that's the real target of the dilution integrated. So again, here also same percentage CV will be calculated and percentage accuracy will be calculated, and it must be within 15%, as we are using ULOQ and LLOQ must be used. So that's why the percentage allowed error is 15%. And re-injection reproducibility. This is a quite interesting one. It is an ability of a method to quantify analyte accurately and precisely after re-injection. Even after, if you give re-injection, it must get a same result. Obviously, we will get the same result. What's the big rocket science in this? If you inject one sample and if you get some result, even after you inject one more sample of the same concentration or same sample itself, you will get the same result. That proving this particular point is called as re-injection reproducibility, because it affects the stability. So the biosamples which has been processed might not be stable in all the conditions. If you inject once now, and if you inject of the same sample after half an hour or 1 more hour, you will get different results because of the stability issues. We need to prove that even after you inject n number of times, you are going to get the same result. This particular logic is called as re-injection reproducibility. Well, why do you re-inject any other sample? After once if you are injected, that sample is over. But when you go for a re-injection, when the sample, the values of the sample seems to be wrong, when the sample result seems to be under a doubt, sometimes there may be a strucking of the LCMS instrument or HPLC instrument, and those situations also we will go for the re-injection. What to be done for the re-injection reproducibility? We need to take one PA batch already run, which was already previously run. We need to take already passed and run and passed. Already completed PA batch must be taken, and that must be re-injected once again, and we have to prove that the same PA results were the same even for the next re-injection also. So the precision and accuracy batch which were already passed, that batch will be taken and again processed for the re-injection reproducibility. Then we have to produce the same results. So acceptance criteria will be obviously same as that of precision and accuracy. So finally, at the end of we are at the end of the validation parameters. This is the stability. Stability, I don't consider this as a validation parameter at all. In fact, regulatory guidelines didn't also consider the stability as a validation parameter, because all these parameters right from beginning to this re-injection reproducibility has to be must and should passed. At 100% level, they have to be passed in order to say that method is validated. But what is called stability here? Stability gives an information regarding what is the storage conditions of the sample, how to shipment of what is the shipment of the sample, what are the conditions to be maintained while you ship the sample, because the clinical site will be of a different site. What is the clinical site here? Clinical site is a thing where you are going to hire the subjects for the BAB studies, bioavailability, bioequivalence studies, or any other phase 1 or phase 2, phase 3 studies. So the clinical site is at one site, and the analysis site is in some other site. So we need to ship the samples. We need to ship the samples from here to there. So we have to have a clear-cut idea regarding the stability of the samples. So stability studies gives information regarding how best the samples are stabilized and what are the conditions to be maintained in order to maintain the stability of the samples. The chemical stability of the analyte in a given matrix under specified condition for given time intervals is assessed in several ways. This gives information regarding conditions such as during shipment, what are to be stability guidelines to be followed, what are the precautions to be taken care. So how many types of stabilities can be possible? Stability can be assessed in different types, like long-term stability, short-term stability, benchtop stability, freeze and thaw cycle stability, like we can talk. The overall concept of stability is same. We need to have LQCs and HQCs. Only LQCs and HQCs, no other concentrations. 3 to 6 replicates. Okay, how to perform this? What I mean to say is how to perform all these stabilities. Freeze thaw stability is there, benchtop stability is there, long-term stability is there. So stock solution stability, process stability, that is auto sample stability. All these stabilities will be performed in the same manner. How? Just we need to take 6 replicates, 3 to 6 replicates of what concentration? HQC or LQC. HQC and LQC and 6 replicates. All these samples must be processed in the plasma and then injected into the chromatographic system. As we are using H and L, the nominal concentration, the allowed error is 15%. If you have used LLO, your nominal allowed error is 20%. As you have used H and L, 15% is. So freeze and thaw, the sample must be freezed and it will be thawed at the room temperature without any assistance. This cycle will be performed at least for 3 times, and after freezing and thawing, then the sample of LQC and HQC must be injected. Similarly, benchtop, and we need to place the sample on the bench of where we are going to exactly perform our experiment and left for some time, maybe 24 hours or how much time you require, and then you have to analyze. Long-term stability, it will be the first date of collection to the last date of collection of the samples. Stock solution stability, which will be prepared, stock solutions for QCs and CC stock solution will be prepared, that stability. Auto sample stability, if we have the auto sampler with our instrument, then we will perform the auto sampler stability, and if you don't have the auto sampler stability, we will skip off this step. So all these conditions were met, and the prepared LQC and HQC prepared samples will be injected into the chromatographic systems, and we are going to record the results. And mean percentage stability will be determined by the formula of mean determined stability divided by mean determined sample stability into nominal concentration of stability by comparing sample into 100. You will get the mean percentage stability. So this mean percentage stability must be more or less, plus or minus 15%. So that's all for the various types of validation parameters, and these are the few references which I have used in order to prepare this PowerPoint slides. I hope the information what I have conveyed to the audience has reached you. I do understand that bioanalytical validation parameters is not that much easy. It requires a lot of understanding, and we need to go through so many times so as to understand the guidelines, the need of the guidelines, acceptance criteria especially. So I hope you might have got some sort of idea regarding this. Thank you so much. Thank you so much for letting me to eat your brains for almost more than 1 hour or so.
Really,
and I wish to stay positive and stay safe. Thank you so much for giving this opportunity. Thank you.
Yes, thanks.
The session may be open for any queries. Thank you.
Really, I appreciate for all the participants to stay for 1 hour. We have started the session at almost 11:45. To know all the participants, they have stayed up to the end. We appreciate for that. We are very much thankful for the ABIPER management, our principal, staff, everyone. Due to some technical issues, we couldn't unable to join some of the participants. We'll sort out this issue very soon by today, and from tomorrow onwards, definitely we can accommodate more participants to the webinar. Try to bear for this, and please excuse this for that. Thank you. And some of them are raised their hand for the questions.
Yes, you can take the questions. Unmute their mic, Dr. Pal, so that they can speak.
Yes, Anita.
All. So participants can ask the questions. So here, if this person is asking, na, so it is not appropriate. Dr. Vanita. Hello.
அதெல்லாம் எனக்கு தெரியாது.
How to put this one? They will raise the hand. It's okay.
We need to unmute Dr. Vanita C so that she can ask her question. Dr. Pal, unmute your mic first, and after that you unmute Dr. Vanita C so that she can ask the question. But you need to unmute your mic first.
Okay, for the participants, you can send a query through all your questions to email ID. We can get back answers from the speaker and we'll send the email. Because this attendees we have done through meeting, it is not in the webinar. Because of that, we cannot unmute and mute the participants. So please send the email to the concern what the mail we have sent. Please revert it back, and we'll get the answers from the particular speaker, and we'll help it out and sort it the issue. Thank you. Thank you once again for all the participants. Sir, Paranjothy sir, can you want to speak anything?
Nothing though, it was very good. So it was a scintillating experience. Like Dr. Ishaq has gone very deep into the subject. So today is very important, right? the nanogram and picogram analysis. And then, thank you very much, Dr.
Thank you so much, sir. Thank you so much for giving this opportunity. I extend to the management principal of ABIPER College, and I heartful thanks to coordinator Paul Richards. Thank you so much for giving this opportunity. Thank you, and all for being with us. Thank you.
Thank you once again for all the participants, those who are joined today. Thank you. We'll meet you on tomorrow at 2 o'clock.
Sure.